Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the examples in inverse Laplace transform. The last class, yesterday's class, we completed the examples of Laplace transformation. Today, we can discuss examples of inverse Laplace transform. So, inverse Laplace transformation. How we can find inverse Laplace transformation for any given frequency? Now, the frequency domain, if it given, convert in the frequency domain to the time domain by using the partial fraction expansion only. By using the partial fraction expansion. Inverse Laplace transformation, you can do by using the partial fraction expansion, the inverse Laplace transformation by partial factor method of all the three cases. Case 1, when as a domain signal x of s has distinct poles, means the different poles is we have. One is s is equal to 0, another one is s is equal to p1 minus p1, and another one is s is equal to minus p2. Different poles we have. Denominator factors we can call it as a poles. Numerator factors we can call it as a zeros. Remember this one. Okay, triple students, they know because they completed the control systems. By using the partial fraction, you can write as a by s and b by s plus p1 and c by s plus p2. Where here I used k1, k2, k3 are the constants. Instead of A, B, and C, you can use A, B, C also. Where K1 you can find out by substituting S is equal to 0 in these two equations. When S is equal to 0, you'll get K1. When S is equal to minus P1, you get the K2. When S is equal to minus P2 in this equation, you'll get the K3. Then apply the inverse Laplace transformation on both sides. Inverse Laplace transformation of x of s is x of t, and inverse Laplace transformation of 1 by s. 1 by s is mu of t, and 1 by s plus a. S plus a is e power minus at mu of t, and here also 1 by s plus a only. 1 e power minus at mu of t. What is the a here? P2. What is the a here? P1. Okay, this is a case 1. You can find out having the distinct poles. And multiple poles we already know the partial fraction, how we can get it, the multiple factors. One pole is s is equal to 0, another pole is s is equal to minus p1, and here there is a two poles are there, s is equal to p2 and s is equal to minus p2, the two poles, because the square is there. You can write as a by s, b by s plus p1, c by s plus p2, and d by s plus p2 whole square. And in this also, you can substitute s is equal to 0 to get k1, s is equal to p1 to get the k2, and s is equal to p square. S is equal to minus p2, you can substitute, you get the k4. So by using the k1, k2 already we get the k4, equate the equations to get the k3 value also. Otherwise, you can substitute s is equal to minus, because it is s is equal to something, s is equal to minus p square or something. Or directly you can compare the constant, compare the s coefficients, or compare the s square coefficient, or compare the s cube coefficient like that. Understood? To find the constants k1, k2, k3, and k4. And then apply the inverse Laplace transformation. 1 by s is mu of t, 1 by s plus a is e power minus at mu of t. 1 by s plus a whole square. 1 by s plus a whole square is t into e power minus at mu of t. When the t is multiplied, the term is a square. In the Fourier transformation also we already discussed that. And here, when the t is multiplied, the Laplace transformation becomes the square of that. Okay, You see here k1 mu of t, k2 e power minus pt into mu of t, and k3 t into e power minus at mu of t, and k4 e power minus at into mu of t. Got it? And the third case we can see here, the third case in general we are saying here, and so on, when it is a square and so on, it is there. You can use it like this. Otherwise, directly can comparing the equations. And third case, complex conjugate poles. Distinct poles, nothing but the different poles. Same poles you can take, the multiple poles we can get. Even though you can write it as by substituting the s values as 0 and s is equal to if any root it is there, substitute and find the constants. And if having the conjugate poles are s plus p1 and s square plus bs plus c, the quadratic expression we got. And for that, bx plus c, you see here the a by s plus p1, and here you are using the bs plus c, that b I am taking the k2 plus k3. When there is any quadratic expression is there in the denominator, the partial fractions we can write it as bs, because here the s is the quadratic expression variable. Okay, bs plus c. Here I use that k1 as a and k2 is a b and k3 is a c. Following, my dear students. Now you can write this denominator as a two parts, and change the above equation is also according to this equation, because we are applying the inverse Laplace transformation. For inverse Laplace transformation, either it is in the form of 1 by s square, 1 by s plus a, or 1 by s plus a whole square. Otherwise a constant a by s plus a whole square plus a square, like that. For that case, you can get the cos omega naught t mu of t and sin omega naught t mu of t. Cos, you can see the cos always I am said that it is a s is in the denominator, but here the s plus a. When there is s plus a means e power minus at is also multiplied. E power minus at is also multiplied. Remember this one. Again, I am explaining here e power minus at mu of t. What is the Laplace transformation? 1 by s plus a. And sin omega naught t mu of t. What is the Laplace transformation? Sin is omega naught by s square plus omega naught square. Now these two is multiplied. E power minus at sin omega naught t mu of t. Now what is the Laplace transformation of combining these two? Wherever the s is there, we can replace the s plus a. So omega naught by s plus a whole square plus omega naught square. If suppose it is a cos e power minus at, cos omega naught t mu of t. What is the Laplace transformation? S plus a by s plus a whole square plus omega naught square. Why? When the cos omega naught t mu of t, the Laplace transformation is s by s square plus omega naught square. So wherever the s is there, you can replace the s plus a when it is multiplied e power minus at. So the above equation is also to get in these terms of Laplace transformation, to get the inverse Laplace transformation. S plus a by s plus a whole square omega naught square means e power minus at cos omega naught. And here the s plus a only, e power minus at mu of t. And now you can see here omega naught by s plus a whole square omega naught square. That is equivalent of e power minus at sin omega naught t mu of t. If suppose if I am multiplied for these two functions t into cos omega naught t mu of t, what is the Laplace transformation? When the t is multiplied, it becomes of square, s by s square plus omega naught square whole square. the t. I already told the e power minus at mu of t. It becomes of 1 by s plus a whole square. The same thing. The t into e power minus at here, the whole square it becomes. Laplace transformation examples. Let see if any time you can ask the inverse Laplace transformation means definitely it requires ROC also. Not for the standard signals, but if any equation is given, let us x of s is equal to given 3s plus 7 by s square minus 2s minus 3 for ROCs. For the first ROC, they're asking that ROC is greater than the 3. For the second one, for the second ROC, less than minus 1. And third ROC is in between of minus 1 and 3. Okay, minus 1 and 3. So at the different ROCs, it's a different equation we'll get for the inverse Laplace transformation. Okay, my dear students. Now let us see. You can write this as s square minus 2s minus 3 as by using the minus b plus r minus square root of b square minus 4ac, or otherwise you directly you can write as x of s is equal to 3s plus 7. Here the minus 2 is there, minus 3. So minus 3 into 1 plus 1. Okay, s square minus 3s plus s minus 3. It becomes of minus 2s only. Take the common here, the 3s plus 7 by, take the first s is a common, s square, not the s square, s minus 3. And for the last two, can take the 1 is a common, s minus 3. So it becomes of 3s plus 7 by s minus 3 into s plus 1. Now you got the factors in the denominator, poles. So x of s is equal to, now I'm writing that is a by s minus 3 plus b by s plus 1. Got it, my dear friends? Now you can equate this function as 3s plus 7 is equal to a into s plus 1 plus b into s minus 3. Got it? Now you can substitute s is equal to 3 in this equation. S is equal to 3 in this equation. S is equal to 3 means b is a 0. B is a 0. 9 plus 7 is equal to a into 3 plus 1 is a 4. 9 plus 7 is a 16. Therefore, a is equal to, what is a is equal to 4? 16 by 4. Now, you can equate the s equations, or you can substitute s is equal to minus 1. Now, I'm equating the s equations, s coefficients 3, a plus b. A is a 4, b is equal to minus 1. B is equal to minus 1. Got it, my dear friends? Now the x of s is equal to a we got the 4 by s minus 3 and plus b is minus 1 by s plus 1. Okay. Now you can write the, for the first ROC, what they are asking, it is a greater than. Greater than means always is a positive value only. Positive means x of t is equal to, whenever the given it is a one equation, ROC is only the one, either it's a greater than, less than, means you can write positive relaxes, it is a greater than. You can write Negative real axis when it is a less than. When the combined equations is given, you can see the value here. First of all, I am writing the ROC of ROC greater than the 3. Means positive real axis only. 4 into S minus A. S minus A means e power at. 3t into mu of t. I am writing the mu of t because it is a greater than. Minus 1 is a coefficient. E power minus at mu of t. The Laplace transformation is 1 by s plus a. What is the a here? Minus 3. So minus into minus is a plus. It becomes 3t. And minus 1 is a coefficient, and e power minus, because it's the plus here, minus t into mu of t. Okay. This is the inverse Laplace transformation for the ROC greater than 3. For the second one you can see it is a less than, they're asking them. Less than the minus 1. Less than the minus 1 means negative real axis. Negative real axis. Less than the minus 1. The ROC, you can write here the 3 is there. ROC is above the 3. And the second one, if I am taking the ROC is less than minus 1, the region of convergence is like this. Minus 1 below the minus 1 ROC. Below the minus 1 means mu of minus t. So x of t is equal to 4 and s minus 3 means e power 3t, but it is not the positive mu of minus t. Mu of minus t. And that mu of minus t also, here you can keep the minus also. Minus into e power at. If it is a minus e power minus at mu of minus t, the Laplace transformation is 1 by s plus c. But ROC is different for this one. Okay. And similarly, already we have the minus is there. Now it becomes plus e power minus t is a mu of t. Mu of minus t. So both are minus t's. Okay, minus e power minus at, mu of minus t is a 1 by s plus a for the negative real axis. It is for the ROC of less than minus 1. But coming to the third one, in the two terms representing in the positive mu of t, and here the two terms representing the negative of mu of minus t. The sign is positive here, the sign is negative. But in this, ROC minus 1 is less than ROC and ROC is less than 3. So observe here, in between of minus 3, minus 1 and the plus 3. So minus 1, ROC minus 1 less than means it is a greater than. ROC is less than 3 means 3. So in between of the ROC is there. So minus 1 is greater than and 3 is less than. So where the value is, the first value is a 3, because the 3 is less than, you can write here the minus 4 e power 3t mu of minus t. But 1 is greater than, is towards positive real axis. 3 value is towards a negative real axis. So the 3 value you can write as a negative real axis values, and 1 we can write it as a positive real axis. So e power minus t mu of t I am writing. Here it is a mu of minus t. Remember my students. It is a mu of minus t. Mu of minus t. Got it? This is a third ROC. When it is a greater than means write all the terms is a positive. Less than means all the terms is a negative. But whenever it is in the range means ROC. 1 is towards the positive means you can write the mu of t. 3 is towards the negative means write as mu of minus t and keep the sign as negative. Got it, my dear students? It is a very important. ROC is very important. To write the inverse Laplace transformation, definitely we require the ROC only. ROC is a positive or the negative. Okay. Then another example in the inverse Laplace transformation. Using the differential equation. Using the differential equation. What is a differential equation? D square. In the Fourier transformation also we did that some examples. Let us take the one example here. Using the differential equation or by using the partial fraction, not the partial fraction, convolution method. By using the convolution method also you can find out the inverse Laplace transformation for the given equations. Now let us see here. The given it is d square y of t by dt square, the differential equation, plus 4 into dy of t by dt plus 5 into y of t is equal to 5x of t with initial conditions they are giving y of 0 minus is equal to 1 and dy of t by dt at 0 is equal to 2. 0 minus is equal to 2. And input x of t is equal to mu of t. This is a given example. Now you can find out solve the following differential equation. Solve the differential equation. Apply the Laplace and apply the inverse Laplace transformation also. What is the Laplace transformation of a derivative function? D by dt of x of t. Laplace transformation is s into x of s. Okay, if it is a square, I am applying the square. Is s square into y because it is a y of s plus 4 into dy of t by dt is s into y of s plus 5 into y of s is equal to 5 into x of t. What is the x of t given? Mu of t. Mu of t, the Laplace transformation is 1 by s. Okay, take the term here, the y of s is a common. Y of s, s square plus 4s plus 5 is equal to 5 by s. Now, write this y of s is equal to 5 by s into s square plus 4s plus 5. Got it, my dear students? Now, what is the s square plus 4s plus 5? There is no any direct roots we have. Definitely, it is a complex roots only. We'll get the complex roots if I am right directly. I am writing here a by s plus b by, and this function you can write as s plus 2 plus j plus c by s plus 2 minus j. You can multiply these two. S plus 2 plus j, a plus b into a minus b means s plus 2 whole square minus j whole square. Simplify this one, s square plus 4 plus 4s, j square is a minus 1 plus 1 will get s square plus 4s plus 5. Got it, my students? These are roots will get a plus b into a minus b. And simplify here to find the a and the b and the c values. What is the a? Substitute any equations. compare the equations or substitute S is equal to 0. S is equal to 0, you'll get the B and C. S is equal to 2 plus J and S is equal to 2 minus J, can substitute. A is equal to 1 and the B is equal to minus J and C is equal to J will get. Okay. So after finding of A and the B, I am directly writing this equation. Y of S is equal to A is 1 by S, and the B is, what is the denominator here? Plus value. B is minus J by S plus 2 plus J, and C will get plus J by S plus 2 minus J. Got it, my dear students? So Y of S is equal to, I'm writing this 1 by S plus, and denominator I'm taking here S plus 2 plus J whole multiply with S plus 2 minus J. What is here? We'll get minus J into S plus 2 minus J plus J into S plus 2 plus J. Now if they simplify here, minus JS plus JS, minus 2J plus 2J, and minus into minus is a plus, J square minus 1, and J into J, J square minus 1. It becomes of a plus 2 totally. If the minus is there, my dear students, so minus J into S plus 2 and plus J into S plus 2. If the minus J into minus J square and J into J plus J square. Okay. J square minus 1. J square is a minus 1 and here the minus 1 is a plus 1 and the minus 1. It is not the same value, my dear students. You're getting the wrong answer. Minus J into S plus 2 minus J, and we'll get the 2 here. S plus 2 plus J and S plus 2 minus J into S plus 2 minus J and S plus 2 minus J, and it becomes A square plus B square, A square minus B square. Okay. So Y of S is equal to 1 by S plus, here it becomes of my plus J, my dear students. This is a minus J. Then you can get it is a minus 2. So plus, and here it is a minus plus J into S plus 2 minus J into S plus 2 get cancelled. Plus J into minus J, it becomes of minus J square, and here also the minus J square. Okay. J into J minus J square, and denominator it is S plus 2 whole square minus J square. What is a J square? Minus 1. Minus into minus is a plus. What is a J square? Minus 1. Minus into minus plus. Totally you'll get the 2. So Y of S is equal to 1 by S plus 2 by S plus 2 whole square. What is a J square? Minus 1. It becomes of 1 here. What did the students? So now we can apply the inverse Laplace transformation. Apply the inverse Laplace transformation. What is the inverse Laplace transformation here? So for 1 by S, you get the y of t is equal to, what is the 1 by s mu of t plus 2 into, 2 is a constant. After getting the 2, you can write as, now I am writing this 1 by s plus 2 into 1 by s plus 2 whole square plus 1 square. You see, it is in the form of sine t mu of t, sine omega naught. What is omega naught here? 1 and s plus 2, because it is s plus 2 is multiplied means e power minus 2t. So 2 into e power minus 2t sine t mu of t is the inverse Laplace transformation. Why I multiply the e power minus 2t? S plus 2 is there. Whenever if it is a s square plus 1 square and 1 is there, that is a sine t omega t only, not the sine t mu of t. What is the sine t mu of t? The Laplace transformation is 1 by s square plus 1 square. When it is multiplied with e power minus 2t mu of t, 2t sine t mu of t, the Laplace transformation is 1 by, wherever the s is there, you can replace the s plus 2 whole square plus 1 square. So mu of t plus 2 into e power minus 2t sine t mu of t. You take the mu of t is a common and right here it is a 1. Got it, my dear students? If any differential equation is given like this, you can find first of all the Laplace transformation by applying the differentiation property. Then after, you can find inverse Laplace transformation for the y of s value. Got it, my dear friends? And in the given equation, see here, we are not using the y of 0 minus is equal to 1 and the d by dt of 0 is equal to 2. When it is useful, whenever you can apply this as a unilateral. Here I am applying the bilateral. If it is a unilateral means s square y of s minus y of 0 is there. And here also s into y of s minus y of 0 minus. Okay. In that case, it is useful. Otherwise, when directly can apply the bilateral Laplace transformation, no need of using the initial values. No need of the initial values. If it is a unilateral means, definitely can substitute the y of 0 is a 1 and the dy of t by dt is equal to 2. Got it, my students? And in another way, in the Fourier transformation also, we can find the inverse Fourier transformation by using the convolution property. Here also, by using the convolution property, find the inverse Laplace transformation. That is 1 by s square into s plus 2. Find the inverse Laplace transformation by using the convolution property. What is the convolution property? F of s is equal to, it becomes of f1 of s and the f2 of s. Let us, this is a given function is f of s, you can assume 1 by s square into 1 by s plus 2. Okay. F1 of s is equal to, I am assuming 1 by s square, and f2 of s, I am assuming 1 by s plus 2. What is the inverse Laplace transformation for f1 of s? F1 of t is equal to, square means t into mu of t. For mu of t is 1 by s, when it is multiplied the t, 1 by s square. And f2 of t, what is the Laplace transformation, inverse Laplace transformation? Because it is s plus a e power minus 2t mu of t. Okay, you got the time domain. What is the convolution? f1 of t with the convolution of f2 of t. The formula is integral minus infinite to infinite. f1 of tau, f2 of t minus tau d tau. integral minus infinite to infinite. What is f1 of tau? You can substitute wherever the t is there. That is a tau. Tau into mu of tau. And here the f2, wherever the t is there, t minus tau. E power minus 2 into t minus tau mu of t minus tau d tau. Okay, mu of tau. What is the mu of tau? Is equal to 1 for tau is greater than or equal to 0. Similarly, mu of t minus tau is equal to 1 when the t minus tau is greater than or equal to 0. And t is greater than or equal to tau, and tau is less than or equal to t. So using these two, tau is greater than or equal to 0 and tau is less than or equal to t, it is in between of a 0 to t only. So I'm changing the limitations now, the 0 to t, tau, and it becomes of 1 and e power minus 2t and e power plus 2 tau d tau. Okay, apply the by parts now. That is equal to, this f of t is equal to, as a convolution, e power minus 2t is a constant because it is t value, and tau into e power 2 tau, integral 0 to t, tau into e power 2 tau d tau. Integration by parts. So what is the integration by parts here? First of all, if I take the tau and apply the integral here, e power 2 tau by 2 minus, take the integral, apply the derivative here, tau 1, and apply the integral for this one, e power 2 tau by the 2, and with the limitations of 0 to t. Again, inside the e power minus 2t, tau, e power 2 tau by 2 minus, apply the integral here again, e power 2 tau by 4 into t with 0. And these are the values of tau. So e power minus 2t, tau is t, e power 2t by 2, e power 2t by 2 minus e power 2t by 4. Upper limit I am substituting with the two terms. And coming to the lower limit, and the tau is a 0 means third term is a 0, and the fourth term is becomes of e power 0 is a 1 by 4. Okay, now you can multiply this e power minus 2t in the inside, e power minus 2t and e power plus 2t. It becomes of e power 0, 1, so t by 2. And e power minus 2t is multiplied with this one, it is also 1, minus 1 by 4 minus, for this function, e power minus 2t is multiplied, e power minus 2t by 4. So final answer is t by 2 minus 1 by 4 and minus 1 by 4 into e power minus 2t. And here there is a, below I am substituting the lower limit means it is a plus, my dear students, plus it will get, okay, plus value. Upper limit, when I am substituting the upper limit, it becomes of a positive value, and lower limit you can substitute, it is a negative values will get. Got it, my dear students? Now the t by 2, mu of t actually, and 1 by 4 delta of t, and 1 by 4 e power minus 2t into mu of t, all the values. Okay. Inverse Laplace transformation can find out by using either the given distinct poles, multiple poles, or conjugate poles, or otherwise by using the convolution property, or if any differential equation is given like this, you can find out the inverse Laplace transformation. Okay, you can find out the inverse Laplace transformation. So some more examples you can solve in the lateral, my dear students. What it? So these are the different methods are using to solve the differential equations or to find out the inverse Laplace transformations. Got it, my dear students? Inverse Laplace transformation. In this also, if I am using this equation is for bilateral Laplace transformation. If it is a unilateral Laplace transformation, see my dear students, if it is a unilateral Laplace transformation, what is a d square y of t by dt square s square y of s minus s into y of 0 minus minus y dash of 0 minus. So y dash of means nothing but dy by dt plus 4 into, and here 4 into d by dt. What is the d by dt? S into y of s minus y of 0 minus plus 5 into y of s. Okay. Now what is the y of 0 minus is given? 1. Okay. And this equation is equal to 5 by s because it is x of s is equal to s square y of s minus s into, what is the y of 0 minus given? 1 minus, and what is the y dy of t by dt y of 0 minus is also equal to the y dash of 0 minus. Is it 2 plus 4 into sy of s minus 4 y of 0 minus is a 1, so minus 4 plus 5 y of s is equal to 5 by s. Why you have got the y by s? Mu of t Laplace transformation. Here s square minus s. The constant here we have minus 2, minus 4. Minus 2, minus 4 we got. So that is becomes of the numerator is becomes. I'm writing here, my dear students. Here itself only. I'm removing this one. This is the equation we got the bilateral. Now I'm writing the unilateral equations. Unilateral equation. S square y of s you can take as a common. Here s square and minus 1. Not the minus 1. Y of s is a plus 4. 4s plus 4s, and here plus 5 and other function is there minus s and minus 2 minus 4 minus 6 minus s is there is equal to 5 by s. 5 by s. S square minus s minus 2 plus 4s y of s 4s into, so y it is a 4, okay, 4s into y of s square plus 4s plus 5, and it becomes of this value. Then what is the y of s here? The y of s is equal to, and take this in the outside, not the outside, of the right side, s square plus 4s plus 5 is equal to I don't get the minus, and minus 2 minus 6 is a minus 2 minus 4 is a minus 6. The 5 by s minus 6 becomes plus 6 here, and minus s becomes of plus s. Okay, y of s is equal to, take the LCM here, 5 plus 6s plus s square, and denominator we have the s, and this also we can multiply, s square plus 4s plus 5. Now numerator becomes second order and denominator is a third order. Directly you can write as a by s and b by bs plus c into s square plus 4s plus 5. Then you can solve like this by taking off plus j by s plus 2 plus j minus j by s plus 2 minus. So unilateral and the bilateral is different. For unilateral, you can use the initial conditions, s y of 0 minus y dash of 0 minus, and can substitute that values and simplify the equation. Got it, my students?